let's go to page 78, and this section is 6.4, and this is the variations on different equation that we form into a quadratic equation. So let's go with some examples. So for example, if you have 6-8, you have 1 plus y plus 3 over y minus 2 equal to 3y minus 3 over 6 minus y. So in this case, what you can do first is you can multiply by common denominator to get rid of the fraction. But because there's a variable in the denominator, there will be restriction. So you need to keep track of the restriction. So for example, like y cannot equal to 2 and y cannot equal to 6. Okay, so those are restrictions. So go ahead and multiply by the common denominator. So multiply by y minus 2, 6 minus y, y minus 2, 6 minus y, y minus 2, 6 minus y. Okay, so again, write it down so you can visualize. So this one nothing to cancel, you can just multiply. Okay, so you can use your FOIL method. And so when you use your FOIL method, you're going to get 6y minus y squared minus 12 plus 2y. Now this one over here, this will cancel out. So again, you can use your FOIL method. So you're going to get actually, another way to do this is make this into common denominator. It's easier, so you don't get as a mess. Again, there are many ways you can do this. Okay, but since we did this, let's go and work it out. But I think it's easier if you make this into common denominator, and then you can, that way you don't have so many to multiply. But anyway, so let's go and multiply. So plus 6y plus 18 minus y squared minus 3y equal to, cancel out, so you can use your FOIL method, equal to 3y squared minus 3y minus 6y plus 6. Okay, and then from here you can go and simplify. Okay, so go and get all the y squares. So start from the highest degree. So you're going to get minus 2y squared, and then do the y term. So you got 6, 8, 14 plus 11y, and then the numbers will give you plus 6, and this will equal to 3y squared minus 9y plus 6. And I'm going to move everything over. So plus 2y squared plus 2y squared, and then minus 11y minus 11y minus 6 minus 6. So you end up with 0 equal to 5y squared minus 20y. And you can divide by 5 to lower your number. So you got y squared minus 4y equal to 0. Then you can do the factoring. You can factor the y. And so you got y equal to 0 or y equal to 4. Okay. And you have to check for restriction, right? So if any one of these is restricted value, then you have to cross it out. So again, so there are variations. So again, there are many ways you can do this. Again, like I said before, you can combine this first before you multiply, so you don't end up with a lengthy equation. Okay, now let's go to next one. Okay, so you have square root of x plus 3 plus 4 equal to square root of ax plus 1. So in this case, when you have radical equation, you want to isolate one square root, one radical, and you square both sides to undo it. So right now this is already isolated, so we can go and square both sides to undo this one. So you have to undo one at a time. So square both sides. So this square will give you x plus 3, and the middle term will be times this together, so it will be plus 8 square root of x plus 3, and the square of this will be 16. And this will equal to ax plus 1. So you're going to repeat, okay? So again, right now you have to isolate this radical before you can square. So minus x on both sides. And then you want to minus 19 because there are 3 and 16, so minus 19. So you end up with 8 square root of x plus 3 equal to 7x minus 18. Okay. Then what you need to do is, if you can divide to lower the number, go and do that. But this one you cannot. So you have to square both sides again. So now you have to be careful. This is going to be 64 times x plus 3. Okay. And this one you're going to get 49x squared. Now in the middle over here, you just times this together, would be minus, to be 2 times 18 times 7. So minus 252x plus 18 squared. We give you 324. Okay, so now I can make it equal to 0, so you can do the factoring. So this would be 64x plus. Okay, so you can just work out the math. So minus 64x minus 64x minus 192 minus 192. So I got 0 equal to 49x squared minus 316 x, and this one would be 2, 3. Okay. Okay, so now you got to try to factor these. Okay, or you can use quadratic formula. Now this is a perfect square, but this is not, so it doesn't help. Okay, so in this case the number is kind of big. So in the book it says use factoring. So let's try factoring. So the way to do factoring is number is kind of huge. Okay. Okay, so so the middle number is minus 316. The number of it, you have to use a master product. You have to multiply these two numbers together. Okay, so you got 49 times 132. So you got 6468. Okay, now to find the correct combination, you just keep going. Okay, so and you have to use both negative to get a negative, right? So -1, -6468, -2, -3234, -3. Would it work? Okay, so -2156. Now the reason we want to do this, so that once you do that, right, so when you get to -4, okay, this is twice as that, so this would be half of that. So it would be -1617. Okay, 5 does not work. 6. So again, this is twice as that, so this would be half of that. So it would be -1078. Okay, 7, does 7 work? Okay, so -7, so give you -924. 8. Now when you get to 8, 8 is twice as that, and this would be half that, so it's not going to work. Okay, 9, -9, does a 9 work? No, 9 cannot divisible by 9, right? 10, 11, okay, 11 is going to work. Okay, okay, so 6468. Okay, so -588. Okay, 12. Okay, so to do 12, you look at a 6, right? So -12. Okay, this is twice as that, so this would be half of that, so it would be -539. Okay, and 13, 14. So when you're doing the 14, so this would be half of that, so it would be -462. Okay, so we started getting pretty close. 15 cannot, right? By looking at this, 15 cannot. 16, there's no 8, so there will be no 16. 17, 18, there's no 9, so you won't get 19. 20, 21, so 21, so you can see that if you can divide by 3 and 7, you can divide by 21. Okay, so 6, so this would be 3 times as that, so this would be 1/3 of that, so it would be -308. And from here you get, let's see, double check. So this would be 329. So we still too much. When you add, you get negative 329. So still a little bit more to go. Okay, 22. Okay, so this is if you do negative 22, right? This is twice as that. So this will be half of that. So it'll be minus 294. And this is it, right? See that? It will match. So this is it. Okay, so now you have to break these things down. So if you try x and 49x, okay? So you have to try 1 and 49. So is this multiple of 49? Let's double check. Okay, 294 divided by 49. Yes, okay? So this would be minus 6, okay? So this would be the inside. So negative 6 times 49 give you negative 294. And this would be the outside, so it would be minus 22. Okay, so this is, so the factoring method is not always the best. So in this case, probably, I don't know, can use complete a square or use quadratic formula. Okay, so from here you can see x equal to 6, and over here you can x equal to 22 over 49. Okay. And you have to double check. Okay, because when you square both sides, when you square the radical equation, you have to check, make sure that all are okay. So you have to put it back in the original, put this back in the original. And once you do that, this answer is no good. So this is no good. So only answer is good is this one here. Okay. So again, we're not going to do take the time to do the checking, but just aware of that, you have to do the checking. Okay. Okay, so let's go to next example. Let's go to example 10. Okay, so you have an x plus y equal to 2, and you have an x y equal to 2. They kind of write it as one long equation, but I want to separate the two. Okay, so in this case, so the regular straightforward way would be just solve for one of them. So you can minus y on both sides. So you got x equal to 2 minus y, and you substitute into here. So you got 2 minus y times y equal to 2, and you distribute, so you got 2y minus y squared equal to 2, and move everything over, so you got 0 equal to y squared minus 2y plus 2. And then you can use quadratic formula. So a equal to 1, b equal to negative 2, c equal to 2. So y equal to negative b plus or minus square root of b squared minus 4a c over 2a. So y equal to 2 plus or minus square root of 4 minus 8 over 2. So y equal to 2 plus or minus so this would be negative 4, so it would be 2i over 2. So y will equal to 1 plus or minus I. Okay. Okay. Now to get the equation, notice to get this equation, instead of doing a substitution, that's another way of doing this equation. Okay, because this is your sum, and this is the product. Okay, so if you remember the root equation from before, you got x squared minus r1 r2 x plus r1 r2 equal to 0. So again, the variable can be flexible, right? You can use x or y. So sum is equal to 2. So these are two roots. Okay, so this x is not this x. Okay, so the sum is 2. So this becomes x squared minus 2x, and the product is 2, so it becomes plus 2 equal to 0, and that's that, right? So you can be flexible with the variable. So again, this x is not this x. And from here, again, you can solve and to get that. Okay. Okay, let's go to example 6, 12. Okay, so you have 1 plus 2 to the n plus 2 to the 2n equal to 73. So what you want to do in this case is you want to rearrange and make this over. So you end up with 2 to the 2n plus 2 to the n minus 72 equal to 0. So you move this over. Okay. Now what you need to do after that is when one term is the square of the other term, notice this is square of that, right? Because this is same as 2 to the n square, right? So when the exponent is twice of that of the other one, means it's a square of the other one. In this case, you want to use a substitution technique. So you want to, for example, like let z equal to 2 to the n. So this becomes z squared plus z minus 72 equal to 0. And then you can go and solve for z. So be 1, negative 72. Now this one is a little bit easier, so it'd be 9 comma negative 8, right? So 9 times negative 8 give you negative 72. When you add, you get that. Okay, so you're going to get z, so you get plus 9 minus 8. So from here you're going to get z equal to negative 9 or z equal to 8. And once you find z, you substitute back. So you got 2 to the n equal to negative 9. You got 2 to the n equal to 8. This one you're not going to be able to get anything. So this one is no good. Now this one you can, now to solve this, what you want to do is you change this into the same base. So it'll be 2 to the 3. And by doing the matching, you can see n equal to 3. Okay, let's go to example 6-13. Okay, you have x to the 4 plus 3x squared minus 4 equal to 0. So again, when one exponent is the twice of the other one, means this is the square of that. You want to use substitution. So let z equal to x squared. So this becomes z squared plus 3z minus 4 equal to 0. And doing the factoring, so you're going to get 4 comma negative 1. So put this number in here, so it'll be plus 4 minus 1. So from here, you're going to get z equal to negative 4, z equal to 1. Then you put this back. So you get x squared equal to negative 4, x squared equal to 1. So when you take the square root on both sides, you're going to have x equal to plus or minus square root of negative 4. So x equal to plus or minus 2i. This one, you take the square root, you're going to have x equal to plus or minus 1. Okay, now you have to pay attention to what answer they're looking for. If there's a find all the real roots, then it would be these, right? But if it's find all, then you want to include all these. Okay. So pay attention to what they ask for. If they're looking for real roots or all the roots. So if they ask for real roots only, then this is no good. If they're looking for all the roots, then everything has to be included.